Hello, so I've been asked to express this single fraction here in partial fractions, and then I've been asked to integrate that between a couple of limits to show that that's equal to this thing over here on the right. So in other words, the hence thing means that once I've shown this in partial fractions, I should use that in this answer here, but we'll get there, okay? So first of all, let's just remind ourselves what partial fractions are. Well, partial fractions are kind of a bit like reversing the process of ordinary fractions. So if, for example, I have 3/4 plus 2/3, okay, and I wanted to combine those together into a single fraction, I had to first of all make the denominators the same. So I look for the lowest common denominator, or I look for a common denominator. It doesn't necessarily have to be the lowest, okay? So the lowest common denominator of 4 and 3 is just going to be 12, okay? So I multiply this first fraction by 3/3. Yep, and I multiply the second fraction by 4/4. Okay, then that just becomes 9/12 plus 8/12. Okay, I add the two things together and I end up with 17/12, I think. Okay, so basically the whole point of partial fractions is we go back to this. Okay, so the whole point of partial fractions is basically saying, right, we have a single fraction. What were the original two fractions? That is all partial fractions are doing, and it's just doing it with algebraic fractions. Okay. So the thing is, we should know the number of fractions that we have to add together. Now, we don't know what's going to be on the numerators, but we sure as hell know what's going to be on the denominators, because the denominators are just going to be these fractions. Because if you think about how we work out those denominators, if you think about, working from separate fractions and combining them together, with algebraic fractions, we can't necessarily work out the lowest common denominator. So to work out a common denominator, we just multiply all those denominators together. So we know that our denominators on our fractions is going to be 1 plus 2x. So 1 plus 2x, okay? But we don't know what's going to be on the denominator, so we just write a letter there. I'm just going to call it a, okay? Then we're going to be adding that to another fraction where the denominator is just our other factor. So it's just 1 minus x all squared on the denominator. Again, we don't know what's on the numerator, so we just write b. Okay, so if you notice, okay, the number of fractions that I have corresponds to the number of factors, okay? So here we've got to be really, really careful, because look here. How many factors have we got? Well, we've got 1 there, and we've got 1 there, haven't we? Well, no, we haven't, because if I write this 1 minus x squared as 1 minus x times 1 minus x, actually, there are 3 factors on the denominator, so therefore there must be 3 fractions, okay? So what is my third fraction? Well, it's going to be some number on the top. Well, what's going to go on the denominator? Well, the thing which is going to go on the denominator is just going to be a single 1 minus x. Okay, it's just going to be a single 1 minus x. Now, when I was learning this, I had real difficulty kind of seeing it, but actually sort of as I've gone through maths, it kind of makes sense to me, if somebody showed me to it, it kind of makes sense to me now, basically. So this is actually your 3 fractions. Now, why? Why do we have this 1 minus x and not over here? Okay, so really this is 1 minus, so if I put this back as 1 minus x squared, okay, this 1 minus x, we didn't have 1 minus x on the denominator, we had 1 minus x squared on the denominator. So let me just give you a quick thought experiment. Let's say we have, let's say we have 1/4 plus 1/3 plus 1/2. Okay, so that's basically what we've got going on here, because of course a 4 is just 2 squared, okay? So that's basically what we've got kind of going on over here, okay? It's just in a slightly different order. Okay, now if I was going to combine these things together, I would look for the lowest common denominator sort of automatically, right? So would you be happy that if I just had, so if we didn't have this 1 minus x squared, for example, so we didn't have this fraction, or we didn't have to worry about this fraction, okay, then would you be happy that on the right-hand side, I would just have 3 times 2 as the lowest common factor, because I just have that multiplied by that as the lowest common denominator, okay, which is going to be 6, okay? But are you happy? Are you happy that if I ignore this kind of like if I ignore this fraction in the middle, then you can see that 4 clearly doesn't go into this denominator, okay? So therefore it's not it's not a common denominator to all 3 fractions, okay? So I have to think about the 4. Okay, I have to think about the 4. And actually, I just have to think about the 4 times the 3. I just have to think about 4 times 3 as the lowest common denominator. The reason being is because 2 will automatically go into 4, which means that when I find the lowest common denominator of just 4 and 3, then 2 will automatically go into that lowest common denominator. So 4 times 3 is 12, and you can clearly see that 2 goes into 12 automatically. So even though we haven't written down 4 times 3 times 2, that is a common denominator, but the lowest common denominator is just 12, okay, because 2 will automatically go in there because it goes into 4, okay? So even though, I could have equally chosen, what's that, that's 24. Could have equally chosen 24, but the lowest common denominator is 12, and 2 automatically goes into that. Hopefully you can see that a little bit. So actually, all we need to worry about is this, because this factor here, the 1 minus x, will automatically go into 1 minus x squared. Hopefully you can see that. So the only idea is that we just look at this right-hand side, here, and we try and combine that into a fraction. So we just treat that as, imagine we knew what a, b, and c were, okay, and we try to combine that just into a single fraction. How would we do it? Okay, well, we're looking for a lowest common denominator, okay, so if we want a lowest common denominator, then what we're going to have to multiply each fraction by? Well, we're looking for the lowest common denominator. We actually know what the lowest common denominator is because they've given it to us. It's 1 plus x times 1 minus x squared. So I've got to basically try and turn each of these denominators into 1 plus 2x times 1 minus x squared. Okay, so remember I can multiply by anything as long as it's 1, so I've got to have the same numerator, same denominator. So let's have a look at this first fraction. Well, I've got a 1 plus 2x. I've got a 1 plus 2x. I want a 1 plus 2x times 1 minus x squared on the denominator. So what I'm going to have to multiply by, I'm going to have to multiply the thing by which isn't there, so it's 1 minus x all squared. Remember, I have to multiply by 1 minus x all squared on the numerator as well. Okay, let's do the same thing for the second fraction. So I've got a 1 minus x squared on the denominator. I want a 1 plus 2x times 1 minus x squared. So I haven't got 1 plus 2x, so I'm going to have to multiply by that there. Okay, so 1 plus 2x. Okay, let's have a look at the third fraction then. So I've got c over 1 minus x. So I've got a 1 minus x, but I want a 1 minus x squared and a 1 plus 2x. So I haven't got a 1 minus x squared. So I've just got a single 1 minus x. To make it 1 minus x squared, I have to multiply by another 1 minus x. So 1 minus x, okay? And I also haven't got 1 plus 2x, so I'm going to have to multiply by 1 plus 2x as well. And the same thing on the numerator as well. Okay, so now basically what I need to do, now I've got this kind of common denominator going on, okay? I now need to work out what each of these, I need to basically write this out sort of as one single fraction. So this is just going to be a, on the numerator, it's going to be a times 1 minus x all squared. And of course, this is all going to be over now my common denominator, which is 1 minus x squared, or I should write it around the other way, I guess. 1 plus, doesn't matter, 1 plus 2x times 1 minus x all squared, okay? So that's my first fraction dealt with. Okay, my second fraction is just going to be plus b, lots of 1 plus 2x, cool, okay. And then c is just going to be, the third fraction is just going to be c multiplied by c multiplied by 1 minus x, 1 plus 2x. Okay, cool. Okay, so the whole idea of doing this is basically I want to try and find out what is a, what is b, and what is c, because then I can just simply put it back into my original partial fraction, so then I can just simply replace them up here. Okay, does that make sense? So so basically what I'm doing now is I know these are my partial fractions. To work out a, b, and c, I kind of combine them together, and then I kind of try and compare them and try and work out what a, b, and c are. So I'm at this stage at the moment. Okay, well, are you happy that both fractions are over 1 plus 2x times 1 minus x squared? So if I just multiply through by that denominator, then the denominators are just going to disappear. So actually that looks a lot nicer. So I've got 2 plus x squared is equal to this thing on the right hand side. Okay, few ways that you can do this. You can either expand it out and then try and compare coefficients. The way which I'm going to do it though is a little neat trick. Okay, I'm going to basically try and get rid of some, so I'm going to sub in some values for x and try and get rid of some of the sort of terms basically. So let's first of all try, I don't know, let's first of all try x equals 1. Because can you see I'm looking at this 1 minus x, I want to make that 0, because then if I make that 0, I want to find a value of x which makes that term 0, because then if I'm multiplying by 0, that term just basically disappears. But also this term over here also disappears because it's also got 1 minus x in. So if x equals 1, then I've got on the left hand side 2 plus 1x, 2 plus x is 1, so 2 plus 1 squared, that's just going to be 2 plus 1, which is 3, okay, is equal to, well, because x equals 1, that term disappears, and this term disappears, so I'm just going to be left with b times 1 plus 2 times x, x is 1, so it's going to be 1 plus 2, so it's going to be 3, okay, so what is b then? So 3b equals 3, which means that b is just 1, okay. Let's do the same kind of thing then and try and get rid of another term or another terms, okay? So can you see that if I put x equals a half, no, wait, sorry, negative a half, if I put x equals negative a half in, so x equals negative a half, okay, then can you see that when x equals negative a half, this term will disappear, And also this term will disappear. The reason why I put x equals negative a half in is because I wanted to try and get rid of the terms with now 1 plus 2x in. So I want to try and get rid of that by putting x equals negative a half in. So, okay, 2 plus negative a half squared. Well, a half squared is a quarter, square the top, square the bottom, and negative squared is just a positive, so it's going to become 2 plus a quarter. Okay, or 2.25, whatever. I'm going to convert that into a fraction, I guess. So 2 plus a quarter is going to be 9 quarters, isn't it? So 9 quarters, and that's going to be equal to, well, what is 1? So I've got a times 1 minus negative a half, and then I'm going to square it. So 1 plus a half, that's going to become, isn't it? So that's going to become all squared. That's going to become 3 over 2. 3 over 2 all squared. That's going to become then 9 over 4. Okay, when I square it. So 9 over 4, a equals that. So therefore, a must just be equal to 1. Does that make sense? A is just going to be equal to 1 because I just multiply through by that, and it just becomes 1. Okay. So I've got a and I've got b. So now I can just replace a with just 1. Okay, I can just replace a with 1, and I can just replace b with 1. And actually, I can go up to my original thing up here, and I can also just replace a with 1 and b with 1. Come on. And b with 1. Okay, cool. And now basically what I need to do is try and work out what c is, because I still don't know what c is. So let's have a look. Well, I guess with here, I could just expand out all of this right-hand side to get rid of all the brackets. But actually what I'm going to do is I'm going to go after this x squared term. I'm going to go after this x squared term. So if I can try and work out just what's going to give me an x squared term, I know the coefficient of x squared is just 1. It should just be 1 from this left-hand side, because I've just got x squared on its own, so it just should be 1. Okay, so then if I can work out what's x squared on this right-hand side, then I just know that that's going to be equal to 1. Okay, so let me try and show you. So what's going to give me an x squared term? So I've got x squared is equal to, well, you're happy there's going to be an x squared in there because I've got 1 minus x all squared. So when I expand that out, it's going to be, well, it's going to be 1 minus x times 1 minus x, which is going to become 1 minus 2x plus x squared. So I know there's a positive x squared term on the right-hand side. So I've got an x squared term from there. Okay, there's no x squared term in there, so I don't have to worry about that. But there is going to be an x squared term in there because I've got two linear brackets being multiplied together. So I've got plus c. So let's expand this out. So I've got c multiplied by 1. Then I've got minus x plus 2x. That's going to become plus x. Then I've got minus x times positive 2x. That's going to become negative 2x squared. Okay, and that's all multiplied by c. Remember, I'm only interested in the x squared term, so let's multiply through by c first of all. So there's c there, there's a c there, and there's a 2c there, basically. Okay, I'm only interested in the x squared term, so I'm only interested in that term. So I know I've got a negative, and I've got a negative 2c x squared on that side. Okay, let's get rid of the x squares. Let's put 1 in front of the x squares, and then we can get rid of them, make it look a little bit more tidy. Okay, so I've got 1 is equal to 1 minus 2c. So basically, what is c? I just have to solve that equation. Okay, well, I know that then 2c is just equal to 1 minus 1, okay, which is just going to be 0. So that means that c is just going to be 0. So that should be a c. So I just know then c must just be 0. Okay, so in other words, the thing on top of this fraction is just going to be 0. It's just going to be 0. So therefore, I can just basically ignore that last fraction. So it is, in this case, just 2 plus x squared over all of that is just going to be that. When I combine that together, I should get back to there. Okay? So I can express that in partial fractions. So now it says, hence show that this integral here is equal to that, okay? Well, if you notice, that thing, the integrand, the thing which I'm integrating, okay, is just what I've just found out, okay? So all I need to do then is just replace that in there, okay? So let's have a look at that. So I've got now the integral between 0 and 1/4 of that thing, which I've just found out is that, okay? So it's just 1 over 1 plus 2x. I'm going to write that around the other way. So it's just going to become 2x plus 1. So not 1 plus 2x, but 2x plus 1. Okay, plus, and I've got 1 over 1 minus x, all squared with respect to x. Okay, let's have a look at that then. Well, bearing in mind, again, this is another type of question. When you're going through your integration, you need to know this identity. You've got this identity going on. So if you have a function on the denominator and the derivative of that function on the numerator, okay, then that is just equal to the logarithm of whatever that function was on the denominator. Okay, so basically you need to have this identity in your head because I can see something is going to happen here. Okay, let's have a look at this. Well, first things first, I'm actually going to separate out into two integrations. So I'm going to treat that as one integration and that as another integration. So let's first of all go the integration between 1/4 and 0 of 1 over 2x plus 1 with respect to x, plus the integration between 0 and a quarter of 1 over 1 minus x, all squared with respect to x. Okay, let's first of all look at this first integration then, I guess. So is this thing, the function and the derivative going on, is that going on here? Okay, well, would you be happy if I call my function 2x plus 1, okay, then what is the derivative? What do I expect the derivative? So if it's the derivative on the top, what is the derivative of 2x plus 1? Well, the derivative of 2x plus 1 is equal to 2. Would you be happy? I'll just differentiate that. That's just 2. It's not a 2 on the numerator. There's a 1. But that's totally okay because I can fudge that, okay? If I want that to be a 2, because that's almost that, okay? So if I just put a 2 there, then what I can do is I can correct that by putting a half out the front, because when I multiply that out, okay, then a half times a 2, that just becomes 1, and it's as if I was never there, okay? So it's like a little fudge factor. I want a 2 on the numerator, because then that would just be this thing going on over here. That's fine, I just turn it into a 2. I just put a quarter there, and it's as if I was never there, okay? So now, this is basically this situation going on. So this first integration should just be the logarithm of whatever my denominator was, so it's the 2x plus 1, okay, and that's between... and that's a half of that, of course. It's a half of that. Don't forget, because I put half out the front. There's still a half there. Okay, so it's a half. The logarithm of that denominator between 0 and a quarter. Okay, what is then this second thing integrated? Well, what I'm going to do, you could do it by substitution. Okay, so if you did it by substitution, all you would do is just simply say, right, that thing in there, just call it u. Let u equal the horrible bit, okay, and then obviously replace dx with something with du in, and then you can basically work out from there. I'm not actually going to do that. I'm going to do it by recognition, because it's much, much quicker. So let's just think about recognition. Let's say, for example, let's do it from differentiation. The whole point of doing it by recognition is calling it the antiderivative, like just basically saying it's the opposite of differentiation. So let's think about differentiation. I'm first of all going to rewrite this as 1 minus x to the power of negative 2. I'm going to raise it to negative 2. So that's all I've done there, just rewritten it using power notation. Okay, let's now think of this. So let's say, for example, I have some function in here, and I raise it to some power, and I wanted to differentiate that. Okay, well, when I'm differentiating it, what do I do first of all? First things first, it's the chain rule, remember, because I've got a function of a function, effectively. So it's the outer-uni rule. So first things first, I raise the power by 1. Raise power by... So first things first, I multiply by that power. So I multiply by n. So multiply by power, okay? Then I reduce that power by 1. So n basically comes down, okay? And then that's left with f of x, okay? But no longer to the power of n, it's to the power of n minus 1. So reduce power by 1. It's just a chain rule, remember? By 1, okay? Then what do? I then multiply by the derivative of whatever my function was. So multiply by the derivative of my function. So I'm going to go f dash x, okay? So that's how we differentiate that. So if we get given like something in the chain rule, and I can see that's something like the chain rule because I've got a function inside. That's my 1 minus x, okay? And that's a bit like being raised to the power of n, basically outside. That's basically what I go on when I differentiate, okay? And I get given n, so when I differentiate it, I get given n f of x to the power of n minus 1 multiplied by f dash of x, okay, multiplied by the derivative. That's what I do when I integrate. Well, that's what I do when I differentiate. Well, if I'm integrating, then all I'm doing is just going back the opposite way, okay? So if I do this first when I'm differentiating, then this, then I just do the opposite in the reverse order when I'm integrating. This is an integration by recognition. So what do I do first of all? Well, I don't multiply by f dash x, I divide. I do the opposite. I divide by f dash x, okay? Then what do? Well, over here, I reduce the power by 1. So I reduce whatever that power was, I reduced it by 1. Well, now what I've got to do is I've got to do the opposite, so I've got to raise the power by 1. Okay, and then what did I do third? Well, third things first, I didn't multiply by the power. Well, I did multiply by the power. If I do the opposite, then I've got to divide by the power. I've got to divide by the power. Okay, so when I'm differentiating, I'm going this way, and when I'm integrating, I'm going this way. So let's have a look at this then with this, okay? So, okay, first things first, I'm going this way, remember, because I'm integrating. So I need to divide by my function, okay? So my derivative of my function. Well, my function is 1 minus x. My function is 1 minus x, okay? My thing inside the brackets is 1 minus x. So the derivative of that is going to be negative 1. Can you see that? Because I differentiate it, it becomes negative 1, okay? So I need, first of all, so when I integrate it, it's going to come, I need to divide by f of x, that's going to be division by negative 1, okay? So that's the first things first. Then what I need to do is I need to raise the power by 1. So I've got 1 minus x, okay, and I need to raise the power by 1. So negative 2 becomes negative 1. Does that make sense? Okay, so then third things first, I need to take the power and I need to divide by it. So what is the power? It's negative 1. I need to divide by the power. So I just need to divide through by negative 1. Well, look, I've got a negative 1 times a negative 1. That's just going to become a positive, okay? So actually the derivative is just going to become 1. Sorry, the integral is just going to become 1 over 1 minus x. It's 1 minus x to the power of minus 1. So it's just going to become 1 over, put it back like that. Okay, and you can verify that if I try and differentiate that, I'll get back to the 1 minus x all to the power of negative 2. I mean, of course, you could do it by substitution if that doesn't make sense. So now it's just a case of putting the limits in, and then we're finally finished. So I've got a half natural logarithm of 2. So I put the quarter in first. 2 times a quarter is a half. Okay, plus 1, so that's 3 over 2. And then I need to put 0 in, and then need to put 0 in, so that's minus the natural logarithm of 2 times 0 plus 1, so that's the natural logarithm of 1, which of course is just 0. Any logarithm of 1 is just 0. Okay, so actually that is just 0 there anyway. Okay, plus, then I put a quarter into this, so I've got 1 minus a quarter on the denominator, so 1 over 1 minus a quarter, that's 1 over 3 quarters, okay, which I think you'll agree that's the same as 1 divided by 3 quarters, multiply the second fraction and flip it. So it's just going to become 4 over 3. Okay, and then here I've got 1 over, so I take away 1 over, put 0 in, 1 over 1 minus 0, that's just 1 over 1, which is just 1, okay. I'll stick all that in a calculator, or you can do it in your head. So half of ln 3 over 2, okay, plus, well, what's 4 over 3 minus 1? Take away 3 over 3, that just becomes minus a third. Okay, and hopefully that's what they asked us to show. That's what they asked us to show, let's find it. There you go.